Students, in last class we discussed about the groups in the periodic table and how to remember elements in the groups. In this class we will discuss about periods in the modern periodic table. Periods. The horizontal rows in the periodic table are called periods. In a modern periodic table there are horizontal rows. Those are called periods. There are 7 periods in the modern periodic table. In the modern periodic table there are 7 periods. These periods are represented by Arabic numericals 1 through 7. Periods are represented by Arabic numericals. First period is the very short period or shortest period. It contains only 2 elements. Second and third periods are short periods. They contain 8 elements. Fourth and fifth periods are long periods. They contain 18 elements. Sixth and seventh periods are very long periods, or they are the longest periods. They contain 32 elements. Here we can see modern periodic table. Horizontal rows are called periods. If you observe first period contains only 2 elements. Those are hydrogen and helium. Second period contains 8 elements from lithium to neon. Third period contains 8 elements, sodium to argon. Fourth period contains 18 elements, potassium to krypton. Fifth period contains 18 elements, rubidium to xenon. Sixth period contains 32 elements. Here you can see 56th element is barium. After 71, lutetium is there. From 57 to 70, you can observe at the bottom of the periodic table. The place of these 14 elements are in between barium to lutetium. So, 18 plus 14, total 32 elements are there in the 6th period. Similarly, 7th period also contain 32 elements. According to new syllabus, 7th period contain 32 elements. If you observe old books, it is given 7th period is incomplete. But at present, in 7th period also 32 elements are there from francium to oganesine. If you observe 88th element, that is radium, after radium 103 lawrencium is there. In between elements are placed at the bottom of the periodic table to get convenient space. From octenium 89 to nobelium 102. The actual place of these elements are in between radium to lawrencium. So 7th period also contain 32 elements. If you observe first period, it contain hydrogen and helium. Hydrogen electronic configuration is 1s1. Helium electronic configuration is 1s2. So we can say in first period, only 1s orbital is filled up. Or in first period, K cell is filled up. K cell contain only 1s orbital. So in first period, 1s orbital is filled up. If you go for second period, in second period, 2s orbital and 2p orbital. 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Total 8 elements are there in the second period, and 2s and 2p orbitals are filled up in the second period. If you observe third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Total 8 elements are there in third period. Third period, 3s and 3p orbitals are filled up. So they contain 8 elements. Observe fourth period. Total 18 elements are there in the fourth period from potassium to krypton. From potassium to calcium, 4s orbital is filled up. 4s1, 4s2. From scandium to zinc, 3d orbital is filled up. From gallium to krypton, 4p orbital is filled up. So in fourth period, 4s, 3d and 4p orbitals are filled up. This is very important. All of you remember this. If you observe fifth period, in fifth period, 5s orbital, 4d orbital and 5p orbitals are filled up. If you observe sixth period, total 32 elements are there from cesium to radon. From cesium to barium, 6s orbital is filled up. From lanthanum to ytterbium, 4f orbital is filled up. From lutetium to mercury, 5d orbital is filled up. From thallium to xenon, 6p orbital is filled up. So in sixth period, 6s, 4f, 5d and 6p orbitals are filled up. 4f orbitals are filled up in the lanthanides. 4f series elements also called lanthanides. These are placed at the bottom of the periodic table for the space convenience. If you observe seventh period, total 32 elements are there in the seventh period. From francium to oganesine. From francium to radium, 7s orbital is filled up. From actinium 89 to nobelium, 5f orbital is filled up. From lawrencium to copernicium, 6d orbital is filled up. From nihonium to oganesine, 7p orbital is filled up. So in seventh period, 7s, 5f, 6d and 7p orbitals are filled up. Actual place of the 5f series elements are in between 7s and 6d. But they are placed at the bottom of the periodic table to get convenient space. 4f series elements also called lanthanides. They are placed after lanthanum. Lanthanides are placed after lanthanum and they resemble lanthanum. That's why they are called lanthanides. 5f series elements also called as actinides. They are placed after actinium and they resemble actinium in their properties. That's why they are called actinides. The number of main cells present in the atom of particular element decide to which period it belongs. The number of main cells present in the atom of particular element will decide the periods to which it belongs. For example, hydrogen and helium atoms contain only one main cell, that is K cell. Hydrogen electronic configuration is 1s1 and helium electronic configuration is 1s2. So they contain only one main cell. That's why they belongs to first period. Similarly, the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon contain two main cells, K cell and L cell in their atoms. Lithium electronic configuration 1s2, 2s1. Beryllium electronic configuration 1s2, 2s2. Boron electronic configuration 1s2, 2s2, 2p1. So they contain two main cells, 1, 2, K cell, L cell. That's why they belongs to second period. So we can say number of main cells present in the atom of particular element decide to which period it belongs. The number of elements in the period depends on how electrons are filled into various cells. Number of elements in period depends on how electrons are filled into various cells. For example, in first period only K cell is filled up. Maximum number of electrons in K cell is 2. So first period contains 2 elements. In second period L cell is filled up. Maximum number of electrons in L cell is 8. That's why they contain 8 elements. Each period starts with a new main cell S subcell and ends when the main cell is filled with respect to the S and P subcells. Except the first period. In first period only S subcell is filled up, S orbital is filled up. But if you observe from second period onwards, each period starts with S subcell and ends with P subcell. Each period starts with S subcell and ends with P subcell. The first period starts with K cell. The first main cell K cell contains only one subcell, that is 1s. This first period contains only 2 elements. Second period starts with second main cell, that is L cell. L cell has 2 subcells, namely 2s and 2p. Already we know L cell has 2 subcells, 2s and 2p. This second period contains 8 elements from lithium to neon. Third period starts with third main cell, that is M cell. This cell, M cell, has 3 subcells, namely 3s, 3p, 3d. Cell has 3 subcells, namely 3s, 3p, 3d. But according to above principle, 3d orbital is filled up after filling 4s orbital. But while electrons are being filled into the cell, 3d gets electrons only after 4s is filled up. So 3d goes to fourth period. In third period, only 3s and 3p orbitals are filled up. That's why third period also contains 8 elements. Therefore, the third period contains again 8 elements, which includes 2 S block elements and 6 P block elements. Total 8 elements. Fourth period starts with fourth main cell, that is N cell. This cell has 4 subcells, namely 4s, 4p, 4d and 4f. But 4d orbital is filled up after 5s. 4f orbital is filled up after 6s. That's why in fourth period 4s, 3d and 4p orbitals are filled up. Total 18 elements are there in the fourth period. Again the fifth period contains 18 elements. That is from rubidium to xenon. Rubidium atomic number 37 and xenon atomic number 54. Rubidium to xenon, total 18 elements are there in the fifth period. There are 32 elements in the sixth period from cesium to xenon. Cesium atomic number 55 and xenon atomic number 86. 4f elements also called as lanthanoids or lanthanides. Ide means hair. Oid means same. They resemble the lanthanum element. They follow lanthanum elements. Their properties are similar to lanthanum elements. That's why they are called lanthanoids or lanthanides. They are from cesium to lutetium. Cesium atomic number 58 to lutetium atomic number 71. There are 32 elements in the seventh period. From francium to oganesine. Francium atomic number 87. Oganesine atomic number 118. Remember, in olden books it is given seventh period is incomplete. But according to new textbooks, total 118 elements are there. So 7th period also contain 32 elements. The 5F elements are called actinoids or actinides because they follow actinium. They are placed after actinium element and they resemble actinium in properties. That's why they are called actinoids or actinides. They are from thorium to lawrencium. Actinides are from thorium to lawrencium. Thorium atomic number 90 and lawrencium atomic number 103. Now we will see one textual question. Complete the following table using periodic table. Directly we are filling answers in the table. First period. In first period only 1s orbital is filled up. In first period maximum number of electrons in 1s orbital is 2. So in first period total 2 elements are there. In second period 2s orbital and 2p orbitals are filled up. So maximum number of electrons in 2s orbital is 2 and 2p orbital is 6. Total 8 electrons. That's why 8 elements are there in the second period. In third period 3s orbital and 3p orbitals are filled up. So total number of electrons 8 and total number of elements 8. In fourth period 4s orbital, 3d orbital and 4p orbitals are filled up. Maximum number of electrons are 2 electrons in 4s, 10 electrons in 3d and 6 electrons in 4p. Total 18 electrons. So 18 elements are there in the fourth period. In fifth period 5s, 4d and 5p orbitals are filled up. 2 electrons in 5s, 10 electrons in 4d and 6 electrons in 5p. Total maximum number of electrons is equal 18. That's why 18 elements are there in the fifth period. In sixth period 6s, 4f, 5d and 6p orbitals are filled up. Maximum number of electrons in 6s is 2. In 4f is 14. In 5d is 10. In 6p is 6. 2 plus 14, 16, 16 plus 10, 26, 26 plus 6. Total 32 electrons. Maximum number of electrons filled in subcell is 32. So total 32 elements are there in the sixth period. Similarly, in seventh period 7s, 5f, 6d and 7p orbitals are filled up. Total maximum number of electrons filled in subcell is equal 32. So total 32 elements are there in the seventh period. This is about periods. We have to remember which orbitals are filled in which period and what are the maximum number of elements in that period and what is the starting element and what is the ending element in that period. Then we can answer all the questions regarding to periods. Students, all of you make notes and prepare well.